Well, hello there, everyone. Good afternoon, and welcome to Morrison Planetarium, and to this presentation of our last show of the day, a tour of the universe. I'd like to find out how many of you were here earlier today to see our other show, Big Astronomy. A few. Okay. Quite a number of you, actually. Well, this show is a little bit different. That show is largely playback. This show is entirely live. And what we're going to be doing is we'll be flying through a three-dimensional model of the universe. We're using a piece of NASA-supported software, which actually you can download for free if you want to run it on your computer. If you're interested in what you see during the presentation today, come and see me after the presentation, and I'll tell you how you can get your hands on this software. But since this is a live presentation, you'll be hearing my voice throughout as I guide you through this tour, and I'll try not to crash into any planets or fly into any black holes. It is a live presentation. I'll try not to keep not to fly too wildly, in fact, because motions across our dome can have an effect on people with motion sensitivity. So we do want to keep that in mind. If, however, you do find yourself feeling a little disoriented because of some of the movements in the presentation, just close your eyes for roughly a minute or so, and that sensation should go away. You'll find yourself back safely on planet Earth. Now, as usual with all of our presentations, during the presentation, this presentation you're about to see, we'd appreciate it very much if you could please refrain from snacking or any kind of photography or recording. This would also be a great time to silence your personal electronics and any light-emitting devices such as cameras, tablets, cell phones. Those should be either turned off or kept tucked away. The light can be very distracting in the dark. If you must exit during the show, please use the doors at the very top of the stairway. And in fact, at the end of the show, please exit out through those doors at the top of the stairway. And we thank you very much for keeping your masks on again during the entire show, even in the dark. What we're going to do is travel through space. So hang on to your seats, and we'll get started in just a moment. Now, one astronomer once said, outer space is not really that far away. It's only an hour's drive if you could drive straight up. And for most purposes, the definition of outer space is accepted to be about 100 kilometers. That's 62 miles. So let's go someplace which is a little bit higher than that. And that would be here. You know what this is? This is the International Space Station, which was, the construction began in 1998, and it has been occupied by human crews since the year 2000. So it's been in operation with humans on board for 21 years. This is the largest thing ever assembled in Earth orbit. It's about the size of a football field. Or for those of you visiting the Academy today, it's about the size of this building, about the size of the Academy. It has that roughly the same size footprint. It's made of a number of different modules and compartments, as you can see, and it's expected to continue operation until possibly until 2030. NASA is trying to see if they can extend that a little bit, or get to work building a new space station. The Chinese and the Russians are already planning to build their own separate station, and NASA is looking at private industry to perhaps build a successor to the International Space Station when it finally runs to the end of its expected lifetime. But it's been going for quite a while now, more than 20 years. It is orbiting our planet at a speed of 17,000 miles an hour, which means it circles the planet once every 90 minutes. And that means the astronauts on board see 16 sunrises and sunsets every 24 hours. They are going fast. And sometimes you can see the space station as it passes overhead. And you can look up online at several websites to find out when the space station will pass over your city. So very, very interesting structure. And that's the direction that the future of the space program is headed. Space stations circling our planet Earth. And this is the farthest that humans have currently traveled. Although we did go farther away than the space station at one time, way back between 1968 and 1972. We went a lot farther than the International Space Station. So let's back away from the station, and we see the limb of the Earth right on the edge there, just lit by a little bit of sunlight there. But as we back away, we're going to have a look at the farthest that humans have traveled from our planet, and that would be what? Our satellite, the moon. So let's have a look at where the moon is right now. We'll turn in that direction, and let's move forward. Let's have a look at the moon. The moon is full tonight. This is the full moon of October, sometimes called the hunter's moon. And tonight it rises at sunset. Now, here in San Francisco, it's been cloudy and rainy all day. But, if you're someplace where it's clear and you can see the moon rising at sunset, it's a beautiful, beautiful sight. And this is the moon the way we are accustomed to seeing it. Let me rotate it a little bit so that the orientation is closer to what we're used to seeing. Now, again, as I rotate this, it looks like the entire sky is moving around you. But if you start to feel a little funny, just close your eyes for a minute or so, and everything will be back to normal after a bit. But you can see the moon has light and dark patches on its surface. This is the side of the moon that always faces the Earth. That's because the moon spins around, it rotates at the same rate at which it revolves around the Earth. So it always keeps the same side facing our planet. We never see the other side of the moon, which is also known as the far side. But we can have a look at it a little bit later on. Let's have a look at the near side. The near side of the moon has these light and dark patches. The dark patches are called maria, which is a Latin word which means seas. And early astronomers who didn't have telescopes thought that the dark patches on the moon were bodies of water. So they called them seas and oceans. And they called them beautiful names like the Sea of Rains, the Sea of Fertility, the Sea of Tranquility, the Sea of Islands. There's also the Ocean of Storms. The light-colored areas were known as highlands. And by the way, those seas, the maria, are not really bodies of water at all. They're actually they're flat plains of dried lava. That lava bubbled up from below the crust about 1 billion years ago, spread out and cooled, covered over older terrain on the surface of the moon, and hardened into those dark gray splotches. The lighter colored areas are where we tend to find more craters, and those are called the lunar highlands. And you can actually see some of the more recent prominent craters. They're fairly bright, and they have splashes of material coming up from underground, which were ejected by the impact which formed these. And all the craters on the moon are the results of impacts by asteroids or comets that slammed into the surface of the moon and exploded as they hit and blew out these craters, which you can see. Well, those are the craters and the highlands and the maria on the near side of the moon. And there are some beautiful mountain ranges as well. Some very large impact basins, which are extremely large, bigger than some of the craters, the single craters that you see here. But we're going to go around to the other side of the moon, the side that we don't normally see. So we're going to look at the lunar far side. Some people mistakenly call that the dark side of the moon. It's not, that's not the name. It's the lunar far side. The dark side of the moon is simply the side of the moon that the sun's light is not shining on. And that can be the near side as well. But this is the far side, the side that we never see from Earth, at least not from the ground. It has been photographed by spacecraft that have orbited the moon. And you can see right away, the far side of the moon doesn't have very many of those maria, not many of those dark patches. And that could be because the crust on the far side of the moon is a lot thicker and wasn't weakened and cracked as easily by impacts as the near side was. So this is the far side of the moon, the side we never see. And this is one place where astronomers think would be a great place to build observatories, because you're shielded, always facing away from Earth, and you're shielded from any of the light pollution or radio pollution coming from our planet. The far side of the moon would be a great place to study the rest of the universe. Well, let's move on. The moon, of course, was visited by humans, as I said, between 1968 and 1972. The Apollo program, put on by NASA, sent a number of people to the moon. 12 of those people walked on the moon's surface, where they collected lunar samples, rocks, and soil. We have a sample of the moon from Apollo 17, just outside the planetarium here. But it took those Apollo astronauts 4 days, actually 3 days, to get to the moon, crossing 240,000 miles. That's a huge distance. Of course, if you were to try to travel that same distance at highway speed, say at 55 miles an hour, it would take you about 4 months, and that's without a bathroom stop. So that's a long distance, 240,000 miles. Now, as we travel farther out into space, we're going to encounter distances that are a lot greater than that. And so astronomers need to use a bigger yardstick to measure great distances. And they like to use one that's based on the fastest thing known, and that is the speed of light. Light travels 186,000 miles per second. Radio waves also travel at the speed of light. And so radio waves, as well as light beams, can travel from Earth to the moon in about 1.5 seconds. They can travel around the world 7 times in 1 second. And you can travel across the solar system in just a matter of hours. As we back away from our from the moon, let's put on the orbits of the planets, so that way we can see where things are. We'll put up the orbits of the moon and Earth, and as we back away, you'll see the orbits of the other planets appearing there. There's the moon circling around the Earth. And as we back away even farther, we'll see the inner solar system with the sun at the very center. Right there is the sun. And the inner planets, the closest one to the sun, of course, is Mercury. The second planet out, Venus. We on Earth are the third planet from the sun. And then fourth is the red planet Mars. So those are the inner planets of our solar system, what are called the terrestrial planets. And there are other bodies in our solar system as well. The terrestrial planets tend to be the smaller planets in the solar system. And there are bigger ones farther out. Beyond Mars is the realm of the Jovian planets, Jupiter, Saturn, Uranus, and Neptune. But the solar system consists of not just planets. There's other material here as well. The solar system has lots of debris. It has lots of leftover material from its formation. And some of that is found in a big gap between Mars and Jupiter. And that is called the asteroid belt. And the asteroid belt is filled with hundreds of thousands of chunks of material. And it looks something like this, if we can give it just a moment, because there's so many objects in the asteroid belt. Takes a while. There we go. There's the asteroid belt, and those are some of those hundreds of thousands of objects between the orbits of Mars and Jupiter. But that's not all there is in the solar system. As we back even farther away, beyond the orbit of Neptune, we'll see that there is another belt of material called the Kuiper belt. Kuiper belt, and that is where we find Pluto and a number of other objects. The Kuiper belt is a lot messier than the asteroid belt, and it looks like this. There are things all over the place, and this is where some of the short period comets come from, as well as other objects known as dwarf planets. Dwarf planets are objects that became a new category of body in our solar system in 2006, when astronomers decided, well, maybe Pluto should be reclassified as some other kind of object, because it really doesn't behave like the other planets in the solar system do. I mean, if you look at the planets and if you look at their orbits, the orbits don't all line up quite the same way. Pluto's orbit, let me see if I can turn that on, is tilted from the orbits of the other planets. Look how much it's tilted there. So right away, that told astronomers maybe Pluto is some other kind of body. It doesn't have the same kind of flat orbit on the same plane. And then it didn't clear out its orbit of that other debris, the rest of the Kuiper belt. And that was one of the criteria that astronomers said constitutes a planet. So because of that, Pluto was reclassified, is no longer recognized as a planet, but it is now called a dwarf planet. It's the biggest of the known dwarf planets. So it went from being the smallest regular planet, to the biggest of the dwarf planets. So that's the story behind Pluto. But as we back away, we'll find our solar system is not alone. There are lots of other bodies in space, in the universe. A lot of them surround us. Our own star, the sun, is just one of hundreds of billions of stars in the Milky Way Galaxy. And as we back away, we are now going to encounter huge distances, so great that we need to use that yardstick of the speed of light. Now, again, light travels 186,000 miles per second, and the nearest star to the sun at the speed of light would take about 4 years to get to. So it's said to be 4 1/3 light years away. That's Alpha Centauri, and that star is about 25 trillion miles away. But astronomers say 4 1/3 light years. As we back away even more, we will find that there is another artifact of humanity which has made it this far out. Our spacecraft haven't gotten this far. Our spacecraft haven't even gotten as far out as light travels in one day. And those would be the Pioneer and Voyager spacecraft. They've only gotten out about 18 light hours. But farther out than that, there is something else that humanity created that has reached this far out. It even goes farther than we are now. And that is our radio signals. Since about 80 or 90 years ago, humans have been sending radio signals into space. These broadcasts some of them were intentional, others were unintentional, the result of nuclear weapons tests and other phenomena. But radio signals from Earth have been radiating out into space, and this is how far our intentional radio transmission have gotten. And that's about 90 light years away from Earth. So that is the farthest we've reached into the universe so far. And you can see that it does include some stars within it. So our radio signals have passed some stars, but they've yet to go as far out as the rest of the galaxy. As we travel farther and farther away, we'll see other stars out there. We'll see our radio sphere shrinking into the distance. And we're going to back away so far that we'll see where we are in our own galaxy, in the Milky Way. So here is our Milky Way Galaxy, which is a huge disk of about 100, well, according to some astronomers, as many as 400 billion stars. And you can just barely make out our radio sphere. I left it on so you can see where we are in the galaxy. About 2/3 of the way out from the center, out on one of the spiral arms. The Milky Way is what's called a barred spiral galaxy. It has a bright center where a lot of stars are concentrated, but delicate, graceful arms winding out from the center. And we're off to the side along one of the arms. About 100 or so years ago, in 1928, an astronomer named Edwin Hubble discovered that the Milky Way is not the only galaxy in the universe. Some astronomers used to think that. But now, well, in 1928, Hubble discovered there are other galaxies. The Milky Way is not alone. He found a particular kind of star in another object, which we now know as the Andromeda Galaxy. And with that, he proved that it was far outside the Milky Way. And in fact, the Milky Way and the Andromeda Galaxy are just two large members of a small cluster of galaxies called the Local Group. And if we back away far enough, we can just make out some of the members of the local group. We can see the Milky Way, we can see the Andromeda Galaxy down below it, and another galaxy called the Triangulum Galaxy. And those are some of the members of our local group. It's a small cluster of about 20 or so galaxies. And every spot you see in the sky now is not a star, but every point that you see is a galaxy. There are lots and lots of other galaxies in the universe. Not only did Hubble discover that the Milky Way is not the only galaxy in the universe was bigger than anyone had thought before, but he found it's also getting bigger still, because what he discovered was that the galaxies are all moving apart from each other. So the universe is expanding, and that knowledge came to us about 100 or so years ago. So now we're going to back away even more to have a look at some even grander structures. You know, the universe is one mind-boggling thing after another. We've got the number of stars in our galaxy, and now we're going to look at the number of galaxies in the universe. We're going to see how the galaxies are distributed in the universe. And we see that the galaxies are clumped together into giant clusters, or superclusters as the case may be, of thousands of galaxies in one group. The texture of the universe is almost spongy, with big empty spots that are separated by filaments of superclusters of galaxies. And the colors that you see here are not the actual colors of the galaxies, but just a way that scientists use to categorize different populations of galaxies and galaxy clusters. So the galaxies really aren't these really nice colors that you see. But as we back away even more, we'll start to see what appears to be some structure where the universe almost looks like a very interesting shape. As we back away here, there we go. We're adding in a number of other clusters and surveys, and here you can see the distribution of known galaxies in the universe. And this is all based on real information again. So as we rotate around this model of the universe, you might notice that it does have a very unusual shape. It looks kind of like a big hourglass. If I rotate around to the narrow part of the hourglass, right in the middle, right there, it looks like there's a big empty area where the waist of the hourglass would be. Do you see that? Is that the real shape of the universe? Well, no, it's not. The parts of the universe of this map that don't have any galaxies in them are simply parts of the universe that we haven't seen very well yet. We haven't mapped them very well, and especially in this area around the middle of the hourglass, because there's something in the way. What's in the way is our own Milky Way Galaxy. Remember, the Milky Way is a flat disk, and as we look along the disk, we're looking right here along this plane where that empty area in this model of the universe is. And the dust and gas in our own Milky Way is blocking our view, so we can't see a lot of galaxies behind it. We're getting there. We're beginning to see some of the galaxies out in that area, but we have to develop our technology a little bit better so we can fill out our map a little more fully. But this is what our current model of the universe looks like. As we back away even more, as we back away from Earth, the farther out into space we look, the farther back in time we're looking. Now we're looking at galaxies whose light left them billions of years ago and is only just arriving at Earth. And the most distant objects that astronomers have seen are things called quasars, which are believed to be the centers of very, very young galaxies in formation. And quasars are out about 10 billion light years away. And those are those orange spots that you see just at the edges of the cones of galaxies. These are the most distant objects that have been found so far. Quasars, quasi-stellar radio sources. They're believed to be the centers of young galaxies powered by the gravity of supermassive black holes. Really amazing thought. And pervading everything, surrounding everything, running through everything that we see, is a faint radiation called the cosmic microwave background, or CMB. This was predicted back in 1948 and was discovered around 1965 or so. And it is believed to be the leftover radiation from the Big Bang, the moment when the galaxies began to expand farther and farther away from each other. So that cosmic microwave background is held by astronomers nowadays to be the best evidence for the Big Bang. And that is as far out as we can go. It is light from about 13.8 billion years ago. And that being the case, that's as far out as we can travel away into the universe, so the only place left to go is back in. And it might occur to you that as we travel back toward the center of our map, it seems that, well, we are at the center of the universe. I mean, it does seem that way, doesn't it? Actually, that's just the result of the fact that we're the ones who made the map. It's a result of our perspective and looking at things around us. If there were somebody else in another part of the universe making their own map, then their perspective would make everything look like they're at the center of everything as well. But, you know, what we see here, as I pointed out earlier, is just part of the universe. Remember, we haven't filled out our map of the universe yet. We haven't seen all the galaxies and galaxy clusters that are out there. But even if we could, we would only be seeing about 4% of the matter in the universe. Most of the universe is not visible. It consists of what's called dark matter and dark energy. And these are very mysterious phenomena that astronomers still don't quite understand yet. The matter that we can see only makes up about 4 or 5% of the universe. Based on the movement of galaxies that they observe, astronomers calculate there's something else out there with enough mass to make galaxies move the way that they see them actually moving. But we can't see what that is. So part of it is called dark matter, which is believed to make up about 27% of the universe. And the rest of it is something called dark energy, which makes up about 68% of the universe. Most of the universe is stuff that we can't see. We're back in our own Milky Way Galaxy, and we see our radiosphere as we approach it. But there's one other thing that I want to point out to you. In our travels through the universe, we've seen how far our radio signature has gone. We've seen other galaxies in the universe. And in all these other galaxies, it makes you wonder, are there other planets out there? Well, yes, there are. Lots of them. Remember, I said since about 1994, astronomers have been discovering other planets in the universe. They have discovered more than 4,000 other planets represented by these circles here. These are stars that are orbited by at least one planet. And we now know of more than 4,000 of these. Are any of these like the Earth? Are any of them Earth-like? And it's actually kind of a trick question, because the word Earth-like doesn't mean habitable. It doesn't mean there's life there. It's used simply as a way of describing the mass of a planet. Its mass is similar to that of Earth, so that means that it's probably a rocky body. That's what the term Earth-like means to astronomers. But in all of these worlds, are any of them able to support life? We don't know yet. We don't know enough about them. We haven't found exoplanets that have the right combination of factors that can support life. It takes a lot of things. It's got to be the right kind of planet. It's got to be a rocky planet. It's got to orbit the right kind of star. It has to orbit the star at just the right distance so that it's neither too hot nor too cold. It's got to have the right chemical composition to have liquid water on its surface, nutrients in its soil, and it's got to have the right kind of atmosphere. So there are lots and lots of conditions that need to be fulfilled before we can consider whether or not a planet is like Earth, in that it can support life. So of all the planets we've encountered in our travels, it seems there's only one that really fulfills those conditions, and that is our own planet, the Earth. It's the only one we know of that fulfills those requirements. That makes our world all the more precious and unique. It's brimming with life, but it's also very fragile, with life depending on a delicate balance of life-supporting conditions. And as we return to our planet, we find that in all the universe, at least for now, as far as we know, there's no place like home. So we're approaching the Earth now, our home planet, the one place that has life on its surface, a place that we need to do everything we can to preserve and protect so it can continue to support the life that exists on its surface. So with that, welcome home. And that concludes this tour of the universe.